Hello, everyone. How are we today? I was going through the messages now, actually. Um, 8 o'clock. Yes, I was actually referring to 5 past 6 UK time. As we are doing this from UK. It would be very curious to know where are you actually. That would be quite interesting. Yeah. So as usual, my name is Stefan. Um, as some of you have actually been with us for the past 4 weeks. This would be a fifth week. Yeah. You know the drill. For those of you that haven't been with us and it's your first time, we will be sharing slides. I do have quite a lot of slides to go through actually today. Unfortunately, we do not have Goran with us due to some other commitments. He will not be here today. But you do have me in case you haven't had enough of me. This is our email. Let's just pin this. Yeah, so if this is the first time that you have missed that you have joined this PCA session, do write send us an email and someone will pick up the email and will send you the other slides that we had in the past. Feel free to connect with us via LinkedIn. I will give you my LinkedIn and I will have a look at Goran's LinkedIn in a second. If you reach out, if you're in London and for example you want to attend some of our events and so on, yeah, feel free. We have people from pretty much everywhere: South Africa, Canada, UK. Nice. New York, Mexico. Very, very nice. Cool. Right, let's just kick off. I do have quite a lot to go through today. I'm not 100% sure whether I'm going to be able to go through everything, because at the same time, I do want to stop here and there and do explain and go over knowledge. I don't want to throw a lot of information at you, because important is to learn and essentially ace your PCA exam. Cool. So we do have week 5, module 4 for this. Analyzing and optimizing technical and business processes. So we're diving into this module 4 of our professional cloud architect journey, analyzing and optimizing technical and business processes. So up until now, we talk about designing and building architecture, but as a cloud architect, your job isn't over once a system goes live. In this module, we're gonna focus on day 2 kind of operations and how to analyze existing setups, ensure that they've met compliance, business goals, and optimize them for better reliability, performance, and costs. So the optimization. Well, something that I want to mention here is the optimization mindset. The PCA exam doesn't just test your ability to build from scratch. Many case studies are standalone questions, which will present you with existing potentially flawed architecture or process, and your goal essentially is to identify bottlenecks or inefficiency and choose the solution that best aligns with the company technical and business requirements. So essentially, it's one of those technical tasks that you do have to do, let's say, during an pair programming tasks, and they will give you a broken API that is fetching data from a specific endpoint, and you do need to do um, some data manipulation over there and display it in a specific way, for example. And this is according to what they require. So this would be, yeah, a similar situation. Cool. So for these topics, there are essentially, we would split them into three, but again, I hope I'm going to cover as much as possible, but cannot guarantee. So looking at the agenda, we have three main areas of focus. So we'll look at how to optimize technical and business processes, and we'll use our favorite company, Symbol Direct, case study to ground our understanding. So and second of all, we are going to dive deep into Google Cloud Data Services, and we'll cover core storage and database options: Firestore, Firebase, Memory Store, Spanner, BigQuery, Bigtable. And finally, there will be a case study. Most probably, this is going to be your homework, which is called Mount Kirk Games case study. This is quite good. Real world example of how to apply this data and analytics services at scales. Okay. Something I forgot to mention, considering the fact that I'm pretty much gonna do this on my own today. I think we should do until 6:45. We are going to do a break. Let's see, 6:45, and then we can resume. Just to give you a heads up and know what to expect in case, for example, you are due to receive a call and you don't want to miss something, or this kind of situations. I like to be upfront and just mention this thing in advance. Okay, cool. So yeah, this is we need to begin and explore the role of PCA and optimizing our favorite company, Symbol. So we'll be looking at this example. So Symbol Direct has several initiatives in progress in addition to the existing web-based retail business, which is focused on footwear and clothing. So as a cloud architect, you need to ensure that you understand the requirements from both business and technical perspective. And once you understand the requirements, you can look at the existing environment. So there will be processes in place that govern how the environment is interacted with. So those processes may meet the requirements, but they need to change if they don't. So just pay attention here a bit. The requirements will always come from stakeholders to serve the business needs, essentially. But you may have to analyze the processes and see if they can still be used, if they need to be modified, or propose new processes. So essentially here it's like you're looking at it and see, is it good? It's like a boolean. Is it good? True. Okay, that's okay. If it's false, then what needs to be improved, what needs to be changed, how needs to be changed, something like that. So we do have a couple of business requirements here, and so Simple Direct's management want to make sure that they can easily scale and handle additional demand when needed. So they can feel comfortable with expanding to more test markets. Streamline for application modernization and new features or products. Um, Ensure that developers spend as much time on core business functionality as possible and not have to worry about scalability whenever possible. Allow for partners to order directly via API. Get a production version of the social media highlighting service up and running, and ensure no inappropriate content. And when analyzing the business requirement, you need to look for duplicate or conflicting items. So um, it's also very helpful to look at other ways of meeting your business requirements if you need to change your solution for some reason. Okay. We do have technical requirements here. I'm not going to go through this. As this is just essentially technical requirements, and just go through this. As I will share the slides. I see. Um, as I'm presenting, as I'm gonna try to pick at the chat. So please bear with me if I cannot pick up the messages as soon as possible. You're the first time here, not affected today. No, it won't affect your learning, because as I mentioned, we will share the slides that from the beginning. Just there is an email over there. Just drop us an email, and we'll send everything, and you can go through everything. But yeah, hope that that helps. Cool. So I want to mention a couple of words about the process optimization. So so let's take a look at how Symbel's direct current release process might look. Right now, it's highly manual and relies on monolithic application. Their developers package on app, check the code in, and literally have to notify QA team manually to test it. Then they manually stress test it, and finally build a VM for deployment. This is definitely not optimal, scalable, or fast solution, realistically speaking. Let's look a bit on how we can optimize this by making it automated and cloud native. So instead of manual handoffs, we moved to a continuous integration and continuous deployment, CI/CD pipeline. So for the source, code is checked into a repository like cloud source repositories or GitHub or GitLab. For building and testing, this action automatically triggers a build using Cloud Build, and Cloud Build runs our automated unit and integration tests. To store this, if the test pass, the one that we just run, Cloud Build creates a container image and pushes it into artifact registry. In terms of security, this is where we add critical automation. We can enable automatic vulnerability scanning in the artifact registry to catch flows. And in addition to that, we can use binary authentication to ensure that only images signed by trusted authorities are allowed to be deployed to our production environment. And then essentially just deploy it. The continuous development phase pushes the artifact into staging or production. When deploying, we would also consider modern deployment strategies like Canary or blue-green deployments to roll out these changes safely without disrupting our users. So a key takeaway for this, it would be to know the CI/CD toolchain and security. So for the exam, it's important that you must recognize the standard GCP deployment pipeline, cloud source repositories, cloud build, artifact registry, GKE, Cloud Run, Compute Engine. You need to pay special attention to binary authentication and vulnerability scanning. For example, if a question asks you to ensure only trusted, approved, or scanned container images are deployed to production, binary authentication, it's almost always your answer. In addition to that, to be familiar with deployment strategies, Canary versus blue green for minimizing deployment risk. So I do have an example here. It's pretty much what I've just I've just mentioned. So I'm not going to go through too deep into this. I'm just going to move on to onto the next one, if that's okay. And I do have one of your favorites in here, which is a diagnostic question. So for those of you that are the first time here, also please do not share your personal details. I do appreciate that LinkedIn it's public and that could be okay, but please make sure you do not share your email or even worse, phone numbers. And yes, welcome Ibrahim, your first time here. So diagnostic questions. Diagnostic question number one: your company places a high value on being responsive and meeting customer needs quickly. The primary business objectives are release speeds and agility. You want to reduce the chance of security errors being accidentally introduced. Should we do A? Ensure every code check-in is peer-reviewed by a security SME. B, even though all of them are A, use source code security analyzer as part of CI/CD pipeline. Ensure you have stubs in unit test and all interfaces between components. Enable code signing and a trusted binary repository integrated with your CI/CD pipeline. Or run a vulnerability security scanner as a part of your continuous integration, continuous delivery pipeline. What do we think here? Let's grab some answers. I'll give you 30 seconds, 1 minute. Okay, D and E, D, B, and I forgot to mention that there are actually 2 correct answers here. I hope I haven't confused you. Yeah. Cool. So yeah, we do have B or second A and last A if you want. So Yeah. B, it automates security checks right in the pipeline without slowing developers down. So yeah, that works great. And E, yeah, automatic scanning catches security flaws early in the CI/CD pipeline while maintaining agility. I'm not gonna speak about the other ones in the interest of time. Um, Container registry versus artifact registry. So let's briefly talk about where we store or build artifacts. So you might be familiar with container registry, but it's currently in maintenance mode. So this means that whilst it's still supported, it won't be getting any new features. So the recommended successor is artifact registry. Not only does artifact registry cover all the standard container use cases, but it also acts as a universal repository. So you can use it in store language specific packages like Maven, NPM, and Python, all in one place. For any new project, artifact registry, yeah, it's absolutely the way to go. Just a takeaway from for the exam from me here is choose artifact registry for the PC exam. Treat container registry as legacy service. If a question, for example, asks you about storing container images, configuring vulnerability scanning for stored images, or securely hosting language packages like the one that I've just mentioned, artifact registry is your target answer. Okay. Cool. So here it's developing Symbols direct procedures to ensure solution reliability. So this before wrapping up with our Symbol direct scenario, let's talk about two crucial procedures for ensuring reliability in production. Um, Chaos engineering and penetration testing. For First, chaos engineering, the philosophy here is if you are afraid of your system crashing, you should intentionally crash them to build resilience. Practically, this means that doing intrusive things like shutting down resources in a single zone to verify that your high availability setup kicks in automatically. You can also use a service mesh to inject faults and timeouts between your microservices to ensure that they handle connection drops gracefully. And so, just a bit on this point, it's like, how was it called? Mutation testing. So, let's get the chat a bit involved on this. And how many of you have actually heard of mutation testing? There is 21 of you online. No, nobody has actually heard about mutation testing. Okay, that's fine. We're going to explain it. So mutation testing is essentially when you do write your tests and they will fail. Then you would write your code. Then the tests will pass. But then again, if you insert a bug on purpose in your code and the test do pass, you do have a problem. Because that essentially it's called that your code has mutated, and that's called mutation testing. So essentially, for the chaos engineering bit, it's a similar situation that you stress test it, you break, you do the most common situations that you could expect just to see how it's behaving. So for the penetration testing, this is where you or hired third party intentionally mimics the behavior of hackers to try and breach your own environment to find security gaps. So this one is massive because it's extremely important to rule. It's an extremely important rule to remember You don't need to inform Google or ask any permissions before executing a penetration test against your GCP resources. But it's good because you're testing and you see exactly what's happening there. So just a key takeaway are this: there's no permission needed for penetration testing, and service mesh for fault injection. So in the first this is a classic exam trap. You will often see distractor option that says something like notify Google Cloud Support 24 hours before beginning the penetration test. You can automatically eliminate that option straight away. You don't need Google's permission to do a pen test on your own infrastructure. That's it. And service mesh for fault injection. If this scenario question asks for the best way to test the resilience of architecture made of microservices, for example, testing how they handle latency or network failures, look for an answer that mentions using service mesh, like Atos service mesh or Istio for fault injection. Cool. So we will have another diagnostic question here. You are developing a microservices application on Google Kubernetes Engine. During testing, you want to validate the behavior of your application in case a specific microservice should suddenly crash. What should you do? Option A, add a taint to one of the nodes of the Kubernetes cluster. For the specific microservice, configure a pod anti-affinity label that has the name of the tainted node as a value. Use Istio fault injection on the particular microservice whose faulty behavior you want to simulate. Destroy one of the nodes of the Kubernetes cluster to observe the behavior, or configure Istio traffic management features to steer the traffic away from the crashing microservice. 30 seconds. Answers in the chat. B. Second A. Well done, Mauro. Yes. B. Yeah, that's correct. So I'm just gonna mention about the second A or B. Using a service mesh like Istio uh, um, always allows you to safely and precisely inject faults like a simulated crash or latency into a specific microservice to test your application resilience. It's essentially what I've just mentioned previously. Just stress test it, see what's happening. Cool. So next we will be speaking about FileStore. You cannot see the question on my on your screen. Do you mean this question? So this is the last question that we've been doing, the last diagnostic question just now. Okay, no worries. Cool. So I was saying, FileStore. Let's have a look at this. Yeah, it's managed and VS and no database. So now we're shifting gears into data services section of our agenda. Remember what I mentioned at the beginning. So let's start by looking at FileStore. The most important thing to note is right there in the subtitle. FileStore, it's a managed network file system, also NFS, and it's not a database. So it's very important to actually be aware of this. So when you need shared file storage, you need three main tiers to consider from depending on your workload. File store basic, file store high scale, and file store enterprise. So for the basic one, this would be standard as it sounds. Um, this is a standard tier for everyday file sharing, software development, and basic web hosting. The high scale, it's if you're dealing with high performance computing, HPC, financial modeling, or heavy analytics. This tier gives you massive through output, up to 26 gigabytes per second. Quite good. And enterprise, as those packages essentially sound like any packages you would actually see uh, on the market, whether it's someone that um, offers a tangible product or just sells websites and so on. So the enterprise one is essentially designed for mission critical application like SAP, GKE, and legacy lift and shift applications. It offers a higher availability SLA of 99.99% and supports data protections via snapshots. Remember, we were speaking about snapshots a couple of weeks ago. Um, Also, note that while the basic tier only allows you to grow your capacity, the high scale and enterprise tiers gives you flexibility to both grow and shrink your capacity as needed. So a takeaway from me for the exam here is that the NFS and lift and shift trigger on the PCA exam in this scenario, if a scenario like this asks you to migrate, let's say on premises legacy application that relies on a shared file system, network attached storage, a NAS, or NFS file store, it's almost always the answer. Do not confuse here cloud storage, which is for object storage, or persistent disk, which is block storage. Also to mention here, high availability. If the question specifically requires SLA 99.99%, for that shared file storage, you must specifically choose enterprise tier. Okay. Diagnostic question. I don't know which one is this, but we do have a diagnostic question. Quick question. Rotimi, can you see this diagnostic question? Yeah, amazing, cool. So you need to deploy a stateful workload on Google Cloud. The workload can scale horizontally, but each instance needs to read and write to the same POSIX file system. So difficult to pronounce. At high load, the stateful workload needs to support up to 100 megabytes per second of writes. What should you do? Persistent disk for each instance. Use a regional persistent disk for each instance. Create cloud file store instance and mount it in each instance. Create a cloud storage bucket and mount it in each instance using GCS views. Let's see the answers. 30 seconds. Let's go. C. C. Third day. Okay. Love your approach. Nice. Yeah, that's true. C or third day. That's correct. So yeah, because file store provides a shared POSIX file system that multiple instances can mount concurrently in read-write mode and easily handles the requirement of 100 megabytes per second. Cool. Next, Firestore. That's an interesting one. Yeah. When should we use Firestore? There are a couple of situations here presented. Yeah, ideal for applications that rely on high availability structured data at scale. That gives you a hint. So just a few words about the Firestore. It's Google's fully managed serverless NoSQL document database. Is designed specifically for applications that rely on highly available structured data at scale. It's absolutely ideal for things like retail products, catalogs, when you need real-time inventory updates, real-time inventory updates, or for sharing user profiles that deliver customized experience. A huge differentiator for Firestore compared to other NoSQL databases is that it fully supports asset transactions. Just as importantly, we need to know when not to use it. So if you need a traditional OLTP relational database with full SQL support, you should use Cloud SQL. If your data isn't highly structured or you're dealing with massive IoT time series data where asset transactions don't matter, look at Cloud Bigtable. If you need to do interactive querying for analytics, OLAP, again, look at something else, BigQuery, for example. Also, if you are just storing unstructured files, images or movies, you want cloud storage. Okay. An exam takeaway would be the NoSQL plus ACID trap. So you'll often see on the exam scenarios requiring NoSQL database for flexible schemas like game states or user profiles, but with a strict requirement that database must support ACID transaction. This is a hallmark of Firestore, data store. But process of elimination, it pretty much works majority of the time. Just here to memorize the non-ideal use cases list on this slide. So the PC exam, it gives you scenarios where Firestore looks like a good fit, but then adds this requires complex SQL joins. This would be making Cloud SQL or Spanner the answer. Again, there are some keywords that you need to pay attention. If you would have require sub-milliseconds analytics, this would be making Bigtable or BigQuery the answer. Okay, makes sense what I'm saying? What's next? So we do have Firestore database mode versus Firestore native mode. I'm going to speak about this and I'm going to give you a break. So when you set up a Firestore database, you actually have to choose between two operational modes, native mode or data store mode, the one I just mentioned before. So on this slide, essentially, it breaks it down. And shows the key differences. So first look at what they have in common. Essentially, both modes offer strong consistency. They have no read limits, and they use YAM for security. However, native mode is the recommended choice for most new applications. It uses documents and collection data model. The massive advantages of native mode are its support for offline data persistence and real-time updates. So this makes it an absolute powerhouse for mobile and web application. It also allows you to use Firebear's rules for security. Um, just be aware of its write limit. It caps at 10,000 writes per second and 500 documents per transaction. As you can, it's very clear as you can see on the slide. So, on the other hand, we have a data store mode. So this mode uses entities, kins, and ancestor queries. So um, you generally only choose data store mode if you have a legacy application, typically an older app engine app that was originally built on legacy cloud data store service, and you need backwards compatibility. So a takeaway for exam, it would be that a comparison, let's just say mobile or web versus legacy. So the decision between those two is usually very clear cut. If the scenario, let's say, because I've been giving you quite a lot of scenarios, if the scenario involves a mobile or web app that needs offline data persistence or real-time synchronization, you must choose Firestore in native mode. If the scenario mentions migrating an older app engine application or specifically mentions entities and ancestor queries, choose Firestore in data store mode. Break. We can do 10 minutes break. So we'll say, no, not 10 minutes. Let's say 7 o'clock, 13 minutes break. Grab some tea, um, grab a drink, maybe a bite you want to. Yeah, let's do break until 7 and then we'll be back. Right, we're back. I hope you had your tea, coffee, water, and you're back. So we will be discussing next. Actually, we do have a diagnostic question. So, game company wants to move their user profiles database to Google Cloud Platform. Easy and simple. Which database should they use? Sorry. Cloud Spanner, BigQuery, Cloud Database, Cloud SQL. Let's see those answers. 30 seconds, 1 minute. D, okay. Anyone else? B, okay. Anyone else? There's no right or wrong answers for this. This is the whole point of the diagnostic question, so we can learn. Just express your opinion. Okay. So it's actually D. Sorry, it's actually C. Even I mixed the A. So it's important here to explain. Data store, now called Firestore, it's highly scalable NoSQL document database. It's flexible schema, making it absolutely ideal choice for managing user profiles, game states, and product catalogs. D, no, because this is a relational database, could technically store profiles. A NoSQL document database is considered the standard, more scalable best practice for the flexible nature of gaming profiles. And there was a B answer. Yeah, so BigQuery is a data enterprise warehouse designed for analytics, all up, not for rapid transactional reads and writes of individual user profiles. Okay. As usual, we will share the slides with you. We do have an interesting comparison here between Firestore and FileStore. Yeah, feel free to take screenshots if you want. If not, just wait for the email in your inbox. Let's clarify sorry, I missed the Firebase. I've used Firebase so many times. Hope you've used it as well, and it's quite interesting. And it's good. It helps you a lot. So let's clarify this three Google Cloud services that sound very similar, but they serve completely different purposes. Firestore, FileStore, and Firebase. It would have been easier if they could have been like named differently. Um, so first we have Firestore on the left side. As we just discussed, this is a fully managed serverless NoSQL document database. It's highly scalable, offers global strong consistency, and boosts a massive 99.999% SLA. It's offline mode and effortless syncing make it perfect for mobile devices. Now, look just below below that at Firebase. Often people do mix those one up. So Firestore is the actual database itself. Firebase is the entire development platform that includes a ton of additional features for mobile and web apps, and it actually uses Firestore under the hood. Um, and finally, on your right side, you can see file store. This is your managed network attached storage, or NAS, for the cloud. It's strictly shared, unstructured file storage. We use file store for heavy compute workflows like media processing, genomic processing, electronic design automation, also known as EDA, or migrating legacy application that require a shared drive. From personal experience, Firebase is interesting. I've used it quite a lot of times. You can actually build your and connect your database with one click and one config file. Um, Use it. It's good if you haven't, of course. Just a takeaway on the exam: don't fall for the name trap. I understand that it can be easy to confuse. So the exam, I went through some questions like this, and the exam writers love to put Firestore, FileStore, and Firebase as a competing multiple choice options, just to see if you are paying attention to the spelling. Um, for a second, if it feels that they try to catch you with something, but it's important to actually do understand and make the difference. So just to have like a schema in your mind, let's say like this: Firestore, NoSQL database, 99.999% SLA, offline mobile synchron. Firestore, NAS, network attached storage, and NFS, share files, legacy, app migrations. Firebase, mobile or app development platform, not just database. It would be much easier if you actually have a look at the platform. You can see it. Cool. Firebase. Yeah, as I mentioned, not just it's a platform, no database. Yeah, so following up now, I'm going to speak a bit in more depth, but not too much. Following up on the comparison, let's look at a little bit deeper on Firebase. As we established, Firebase is not just a database, it's a comprehensive application development platform. It consists in multiple functionalities that allow to build, test, run, and manage entire life cycle of your mobile and web application. Google thinks of this platform in three main buckets: develop, earn, and grow. When you are developing a new app, Firebase gives you the components you need, like compute, storage, and authentication, user authentication. Once the app is running, it helps you monitor crashes and users' experiences. And finally, it provides analytics to help you understand your most valuable users, so you can personalize their experience and apply user retention here. So again, for the takeaway for the exam, there are two crucial things to associate with Firebase. If a scenario involves building a mobile app on Firebase and needs a database, Firestore is almost always the correct underlying NoSQL choice. Watch out for Firebase authentication. If a question asks for the easiest way to add secure user sign-in, including social logins like Google, Facebook, whatever you want to add over there, to a mobile or web app without building a custom identity solution, Firebase authentication is the answer. As I said to you, it's quite intuitive and it's fairly easy to use, especially if you've been in the tech world for a bit. Yeah, it's fairly easy. Next, we do have a diagnostic question. Your development team has created a mobile game app. You want to test the new mobile app on Android and iOS devices with a variety of a variety of configurations. You need to ensure that testing is efficient and cost effective. Should you create an Android and iOS VM on Google Cloud, install the mobile app on the VMs and test the mobile app? Should you upload your mobile app in the Firebase test lab and test the mobile app on the Android or iOS devices? Create an Android and iOS containers on GKE, install the mobile app on the containers and test the mobile app. Or the last one, upload your mobile app with different configurations to Firebase hosting and test each configuration. 30 seconds. Go. Oh, someone is eager, Beaver. B. Okay. Second day, I like Mauro. He's still he's in the spirit of the slides. Maybe I should change them actually. B. Second day, yeah. It's easy here. Firebase Test Lab is a cloud-based testing service specifically designed to test mobile apps on a wide variety of real physical Android and iOS devices, handling different models, screen sizes, and OS versions perfectly. It's with the screens, it looks like Android Studio when you're actually setting up your type of phone. The difference is that this one is testing for both, for iOS and Android. Cool. Memory store. Let's have a look at this. We have one of those interesting schemas or graphs, if you want to call them like this. I find them quite interesting and quite helpful. So yeah, Sketchnote, I think it's called this. So Memory Store is Google's fully managed in-memory data store service. It supports two of the most popular open source caching engines, Redis and Memcache. I have to admit, I've heard of Memcache, but I haven't used it. But Redis, yes. The core concept is that Memory Store sits between your application and your main database. It acts as a high-speed caching layer that stores frequently accessed data in memory, which drastically reduces latency and takes the read load off your primary database. So looking at the use cases, it's perfect for things like gaming session stores, real-time analytics, fast data ingestion for social media, and managing leaderboards or counters. If you're using Memory Store for Redis, you have two availability tiers. The basic tier provisions a single instance, which is great for simple caching, where data loss isn't a disaster as it carries no SLA. However, if your cache is critical to your application survival, you want standard tier. This gives you a secondary replica deployed across zones, protecting you from zone failure and providing with 99.9 availability SLA. Finally, because it's 100% compliant with open source Redis and Memcache, you can integrate with your existing caching layers to Google Cloud with literally zero code changes. Again, takeaway from here, exam takeaway, the latency caching trigger. So on the exam, if an application is suffering from database read bottlenecks, let's say they call it like this, or slow database queries, or specifically requires sub-millisecond data retrieval, your immediate answer should involve introducing memory store as a caching layer. And also we need to look at the comparison between standard and basic tier. Pay close attention to the availability requirements in the prompt. If the scenario mentions that cache requires high availability or needs to survive a zonal failure, you must specifically choose the standard tier of memory store for Redis. Next, let's have a look at Spanner. Cool. What workloads fit Cloud Spanner best? So we do have 4 categories, let's say here. So Cloud Spanner, which is Google's enterprise grade, globally scalable relational database. In this slide, we outline 4 main scenarios where Spanners is absolute best fit. So first we have a standard RD BMS, manually sharding a database to achieve scale is incredibly difficult, and it's a nightmare to manage. Cloud Spanner completely eliminates the headache by giving you strict relational data and massive scale out of the box. Second of all, if you just need scalable relational data, if your traditional relational database is maxing out, you do not have to rewrite your entire application to fit a NoSQL database. You can simply move to Spanner, and that's it. Third of all, for exceptional manageability and high availability, Spanner is highly automated, allowing for entire schema changes and patching with absolutely zero planned downtime. It offers a staggering 99.999 availability SLA. So fourth of all, multi-region deployments. So while many customers just use regional instances, if you need a global presence, Spanner lets you write once and automatically replicates your data to multiple regions with strong global consistency. So a takeaway here would be the global relational trigger in your exam. If a scenario requires a database that must support ANSI, SQL, or strict relational schemas, and needs to scale globally, or mentions that manual sharding has become a bottleneck, Cloud Spanner it's your answer here. Do not confuse it with Cloud SQL, which is regional and has its limits on vertical scaling. The 99.999 SLA, it's highly available relational database. It's required, and the prompt specifically asks for 5 nines availability. Spanner is the only relational database on GCP that fits this requirement, essentially. So if you see 99999, straight away Spanner. That doesn't mean you should not pay attention to anything else, but most probably. So now that we know why Spanner is so powerful, we need to understand its limitation. So for the exam and in the real world, you must know when Spanner is not the right choice. Emphasis on not. So first, it's not. The biggest step here is to keep in mind that migrating a traditional RD BMS to Cloud Spanner is not a straightforward process. We can look at 4 scenarios where Spanner might not be a good fit. So first, it's not meant for simple lift and shift of existing database. Second, if your legacy database relies heavily on in-database business logic, meaning it uses a lot of triggering and stored procedures, moving to Spanners will be a major architectural challenge and implicitly a headache. Furthermore, if your application has strict engine compatibility needs with standard open source database, Spanner will require significant application rewrites. And finally, let's talk about performance profiles. If your application is extremely sensitive and requires very low latency, we are talking millisecond, nanosecond, like fast, or low single digit millisecond response time, Spanner isn't quite that fast. Similarly, if your database handles a lot of analytics or all-up type queries, Spanner is not the optimal engine. So a takeaway for the exam would be the anti-spanner triggers. Again, pay close attention to scenario constraints. If the requirement is simple lift and shift, we've clarified, or a simple lift and shift over SQL or Postgres database, just choose Cloud SQL. That goes there. If the application relies on stored procedures and triggers, lean towards Cloud SQL or bare metal compute engine for legacy SQL Server or Oracle. If the requirement is single digit milliseconds latency, you need Cloud Bigtable or cache like memory store. If it mentions analytics or all up workloads, your answer is almost certainly BigQuery. Okay. Diagnostic question. I don't know which diagnostic question is this, but let's do it. So your organization is developing an application that will manage payments and online banking accounts located around the world. The most critical requirements for your database is that each transaction is handled consistently. Your organization anticipates almost unlimited growth in the amount of data stored. What Google product should your organization choose? Cloud SQL, Cloud Storage, Cloud Firestore, Cloud Spanner. 30 seconds. C. Okay. Cloud Spanner, that's C. No, that's D actually. Cloud SQL, that's actually A. Okay. It's actually Cloud Spanner. We've been just speaking about this. Okay. Normally I don't address this, but let's look at options. So Cloud Spanner, yes, it would be the perfect fit. It provides strict consistency required for financial transactions, the relational structure needed for banking, and the availability to scale globally and unlimited. It says here unlimited. um, unlimited growth for the amount of data stored. So this it essentially fits the requirement of this exercise. Let's look at the answers. So I see some of the answers. They say C, which it's yeah. Firestore it's a great NoSQL document database, but for a global banking and payment application, a relational database with SQL capabilities is the industry standard for financial consistency. And we saw Cloud SQL. Yeah. So whilst Cloud SQL is a relational database that handles consistency well, it's a regional service, and it does not scales unlimitedly or globally to meet the requirements for the bank accounts located all over the world. So as we've been mentioned a couple of times, it's important to actually pay attention at keywords. Okay. BigQuery. So let's dive into BigQuery. This is essentially Google's enterprise data warehouse. To manage this effectively, you must understand the organizational hierarchy. Project followed by dataset, then tables, and finally partitions. So this would be, imagine this as a pyramid, and you would be looking at levels. I think I find it like the easiest way to remember this. There are a few critical rules for how BigQuery operates that directly impact performance and cost. So first, remember that BigQuery it's a columnar database. For every query, it executes a full column scan. Because of this, your cost and performance are determined by the exact amount of data scanned. Geography is also vital. You set the geographic location of your dataset only at the time of creation. If you're running a query that joins multiple tables, every single one of those tables must reside in the same location. Similarly, if you want to copy a table using simple command line tools like BQCP, the source and its destination must be in the same location. If you need to remove a data set across region, you will need to use BigQuery data transfer service instead. And finally, keep in mind, while many things in GCP are flexible, datasets names are case sensitive. So you do need to pay attention to this. I have a few takeaways for the exam on this bit. The location. This would be a frequent exam topic. If a query fails because tables can be found or joined, check if they are in different regions. One is in US and one is in EU, for example. You cannot join tables across different geographic locations in a single query, as I mentioned before. Cost optimization. Since BigQuery charges based on data scan, the exam would often ask how to reduce costs. And the answer is almost always to use partitioning or clustering to limit the amount of data the engine has to read. And moving data. Know the tool for the job. Use BQCP for fast same region copies, but use BigQuery data transfer service for moving data between regions or from external resources. So still on the BigQuery, on security and access control on the BigQuery are handled primarily through identity and access management roles, but these are applied at the dataset level rather than individual tables. So this slide, I know it's quite a lot of information here, but it provides a breakdown of common predefined roles you will use. So, for instance, the data viewer. This role is perfect for analysts who only need to see the data and the metadata, while the data editor roles adds the ability to create, update, and delete tables within the dataset. On the execution side, you have job user role. This is essential because in BigQuery, the ability to see the data and the ability to run a job, to query the data separate permissions. A very common and high value practice is to separate your data storage and compute. So you might have a data project that holds all your data sets and separate billing project where analysts run their queries. This allows you to precisely track and control which departments are incurring query costs without duplicating the underlying data. So essentially, you're segregating, you're separating, or segmenting. I don't know how many synonyms, but I think you do get the idea. Just so you have a better control of your costs, and considering the fact that using this tool, it can be fairly expensive. So I do have a few takeaways here for the exam, just to pay attention with. Remember that BigQuery permissions are typically managed at the dataset level. So if a question asks how to give a group of users access to a specific set of tables, the standard answers involve grouping those tables into a dataset and applying the YAM role here. If you see a scenario where you need to charge query costs to specific department or projects while keeping a centralized data repository, look for the answers that involves assigning job user roles in the department's billing project and data viewer roles in the central data project. Job user versus data viewer. A classic distractor is giving someone the data viewer role and wondering why they can't run a query. They must also have job user role in the project where the query job it's actually executed. So just do pay attention with those aspects because they're important. Sorry. Right. So on this bit, we're going to speak a bit about the controlling access to data sets, considering essentially just linked with what I've just mentioned. So building on the predefined roles we just covered, BigQuery allows for even more granular security at multiple resource levels. While we typically apply permissions at the projects or dataset level, we can actually get much deeper to satisfy strict compliance and list privilege requirements. So we can restrict access at the table or view level using authorized views. This allows you to share query results with users without giving them access to the underlying raw data. In addition to that, we can implement column level security and dynamic data masking. So this is incredibly powerful. For sensitive data like PII, you can hide specific columns from unauthorized users without needing to modify your existing queries. And finally, you can have row level security where you can hide entire rows based on users' role or identity. These policies can coexist with your other security settings to create a robust layer defense. a takeaway again, some takeaways here. If a scenario asks you to share specific aggregated data with third party without giving them access to the source tables, authorized views is your primary answer. Protecting PII. So if the requirement is to prevent certain groups like junior analysts from seeing sensitive data like credit card numbers or emails in a large table, while still allowing them to query the rest of the table, look for the column level security or data masking. This is good one. And row level security for regional compliance. On this bit, if a question describes a scenario where users in France should only see French customer data, while users in Germany should see only German ones, and so on, within the same table, row level security is the correct one, because essentially you're just splitting them. That's it. Yeah. So I think we kind of went over this bit, and this is essentially explains it, and shows it, how it's being done. So this authorized views, it I would say it's the most powerful security features in BigQuery. A view is essentially a virtual table defined by SQL query. Your query is exactly like you would a standard table. This query results contain the specific data from the tables and fields you define in the SQL statement. So the real value comes when you authorize that view. This allows you to share specific query results with particular users or group without giving them any access to the underlying new table. As you can see in this console, you can manage the permission directly of that dataset level, selecting the specific project dataset and view what you want to share, essentially. I think, yeah, no specific takeaways on this bit, as I've already mentioned, but it's worth like going over this again, and seeing exactly what's important, maybe making some notes and so on. Okay, cool. So we do have here, we do need, let's say we need moving forward, just like we talk about storage, transfer service to upload data to your GCS buckets. A similar service exists for BigQuery. It's called BigQuery Data Transfer Service, and has a wide choice of different sources of your data. But the target is always BigQuery. So this essentially automates the movement of data into BigQuery from a variety of sources on a scheduled, fully managed basis. So we do have a bunch of options here, as you can see in the console screenshot. It supports a wide range of popular sources, including Amazon S3, Google Ad Manager, Google Ads, and even simple cloud storage buckets. One of its most powerful features is the ability to initiate data backfills. So if you experience an outage or discover a gap in your historical data, you can easily trigger a backfill to ensure your analytics environment remains complete and accurate. So yeah, a takeaway from this, it would be, let's talk about scenarios again. Let's say if a scenario requires recurring and scheduled ingestion of data from third-party SaaS application like Google Ads, all of these services we mentioned, into BigQuery. BigQuery data transfer service is the correct answer. Easy there. Recovery via backfills. Be aware that this service is specifically designed to handle data backfills to recover from outages of historical data gaps. If a question asks you for a managed way to re-ingest a specific historical window of data, this service is the right choice. And now we need to look at service versus manual. So remember that BQ load, it's great for one-time manual loads. The data transfer service is the architect's choice for automated and managed data pipelines. Nice. So we'll be looking at this schema to understand a bit better. Sorry. So when designing your data ingestion strategy for BigQuery, you'll generally choose between two common architecture, batch or streaming inserts, which you can see them on the screen. So on the left, you see the batch approach. This is common for migrating data from on-premises or other clouds. You typically move the data into cloud storage first and then run a load job to bring it to BigQuery staging tables. This is highly cost effective because BigQuery does not charge for load jobs from cloud storage. On the right side, we have streaming architecture. This is used when you need real-time insights from sources like Cloud, SQL, Spanner, or Bigtable. We often use Cloud Dataflow as the processing the transition this data on the fly before hits BigQuery. While this provides much lower latency, keep in mind that BigQuery charges an additional fee for both streaming inserts and streaming reads. A takeaway here would be just put it in balance and say cost versus latency. It's key architectural trade-off for the exam. If the scenario emphasizes cost effectiveness and the data doesn't need to be available instantly, choose batch loading via cloud storage. Load jobs are free, remember. If the scenario requires real-time or near instant analysis incoming, choose streaming inserts, but acknowledge the additional cost. There was some resource, the ingestion chain. You will see it in the slides on the with the links. It's important to memorize the common tool chain for streaming the ingestion chain. I'm not going to read it, but it's just have a look at the links. What do we have next? Still on BigQuery, sharing datasets with others. So when you want to share a dataset beyond the specific individual or groups, you can use specific identifier all authenticated users. Adding this principle essentially makes your dataset public to everyone with a Google account. However, there is a very important distinction to understand regarding how these users interact with your data. Authenticated users do not run queries. within your project. Instead, they use BigQuery within their own project to query your public data set. This leads to a critical point about billing, the cost of the query, and always assigned to the active project from where the query is executed, not the project where the data is stored. You provide the data, but users provide the compute engine budget. Um, so on this bit, it's, let's say in an exam scenario, asks for the most efficient way to share a large data set with the general public or wide range of external partners without managing YAM entries. All authenticated users is the principle to use here. Um, so I would say billing responsibility. This would be a high probability exam concept. So remember that for public or shared data sets, the query requester pay for the compute. So if you see a question about how to share data without incurring massive query costs from external parties, it's like split the bill model. It would be an intended answer. So also the data viewer role, to make the dataset public, you typically assign BigQuery data viewer role to all authenticated users, principal at the dataset level. Okay. So on next, we do have sharing queries with the others. So in addition to sharing raw data, BigQuery makes easy to collaborate by sharing the actual SQL queries you write. This is mostly used for collaboration within the team. So before you can share a query, you must save it first. You can even share incomplete or invalid queries if you are working with a peer to debug a complex statement. So as shown in the console menu, you have three visibility levels: personal, project, and public. The first one, only you can see and edit the query. The project one, the query is visible to anyone in the project who has required permission. No brainer here. Public, the query becomes visible to anyone that has a direct link to it. This is like one of those situations you see in Google um, when you share a Google file on the drive with someone, editor, viewer, and someone that has a direct link, essentially. Um, so, exam takeaway: collaboration tools and saved queries versus views. So for the collaboration tools for the PC exam, distinguish between sharing data via dataset permission authorized views and shared logic via saved queries. If a scenario, let's say it's asks for the best way to let a team of data scientists peer review each other's SQL, as we mentioned before, without manually copying and pasting text, project level and saved queries is the correct answer. Saved queries versus views. Remember that saved query, it's a collaboration tool for sharing code snippets. Whereas an authorized view, it's a security tool for sharing data results without revealing the underlying tables. So when you have specific SQL queries that need to run on regular basis, for example, daily aggregation of sales data, you should use scheduled queries. This feature actually leverages the infrastructure of the BigQuery data transfer service to handle the automation. As you can see in the configuration panel, you can define exactly when the query repeats, such as daily for specific time. One very helpful automation is that if your specified destination table doesn't exist yet, BigQuery will attempt to create it for you automatically. So finally, for production environments, you can configure these scheduled queries to authenticate as a service account. This ensures that automation continues to run smoothly, even if the individual user who originally set up the schedule leaves the organization. Something to remember here. It's very important. So for the automation tooling, if the exam asks for most efficient way to automate a recurring SQL task within BigQuery, like daily reporting or periodic data cleaning, the answer is scheduled queries. Service on the service account best practice, always look for mentions of using service accounts for scheduled tasks. This is core Google Cloud security and reliability principle that frequently appears as the correct way to handle long running or automated processes. And infrastructure dependency on this bit, remember that scheduled queries are technically a part of BigQuery data transfer service. So you might see this connection mentioned in more technical questions about how BigQuery automates data movement. We do have this one. Want to have a look and see what I'm gonna try to, as I said, I'm gonna try to cover as much as possible, but we're not gonna have too much time on this. And obviously, all the slides will be sent to you, so you can go over these ones. To improve performance on the query result caching. So to improve performance and reduce costs for frequently run queries, BigQuery automatically caches query results in a temporary table. There is absolutely no charge for queries that return results directly from the cache. Sorry. However, there are several specific rules that about how this cache behaves. So first, the cache is per user. If two users run the exact same query, the second user will not benefit from the first user's cache result. Second, these results are generally stored for approximately 24 hours. Through the lifetime is extended each time a query hits the cache. So there is also a size limits of 128 megabytes compressed for cache results. So, and finally, if you're doing performance benchmarking and you want to see true execution time of a query, you can manually turn caching off to ensure that you are testing the full processing engine. So I would say there would be three keys, key points for the exam. Cost saving. So if you ask how to minimize cost for dashboard or report that multiple people look at what they look at throughout the day, one key answer is leveraging query caching. Remember, cached queries are free. The per user restriction that I've mentioned before, just to pay attention with this scenario questions about shared dashboards, because the cache is per user. A shared dashboard used by 100 different people will still incur 100 separate query charges unless you use a single service account to fetch that data. And determinants for caching. For a query to be cached, it must be identical to the previous one. If a query use non-deterministic functions like current timestamp, let's say, BigQuery will not cache the results because the data is expecting to change every time the query runs. So you need to pay attention with this. Unfortunately, we're pretty much close to the end. I will still have quite a few bits to go over, but we don't really have much time. Recording will be sent to you. Yes, we do take, in case you're wondering, we do take attendance automatically of everyone that has been online. There will be a case study. Mm, just bear with me. There will be a case study for this, but you will have to have a look at this once we send the slides. Yeah, you do have our email address. I have shared with you our how have I done? Yeah, I have shared with you the email address, the LinkedIn. Feel free to reach out if you have any questions or curiosities or anything. Something to remember for next time. We will be doing the session on Monday, not on Tuesday. That will be the last session. And I will speak with Goran. We do actually have some vouchers. I'm not 100% sure how many, but that would be 50% discount for the exam. And yeah, we will be doing this randomly. For some of you or one of you, I'm not 100% sure, but we'll have to double check this with Goran. Thank you very much, and I will see you next week on Monday, same time. Thank you. Bye.